good morning or afternoon, depending on where you are. I'd like to give a warm AASHTO welcome to Joe and Julianne from New York State DOT to talk about their use of the bridge design software at their state. I'll let them introduce themselves a little bit more, and then we can get started with the webinar. Thank you for joining.
All right, thank you, Ben. I'm very happy to be with you guys this afternoon. My name is Julianne Fuda. I'm Director of the Structures Design Bureau within the Office of Structures at New York State Department of Transportation. So I've got 15 years of experience designing new and replacement bridge projects as well as rehabilitations, including accelerated design and construction projects, as well as responding to emergencies across the state for flooding, bridge washouts, bridge hits, and critical finding conditions, also known in New York State as red flags. I am also a member of the AASHTO Committee on Bridges and Structures, a part of the Steel and Metals Committee, as well as the Concrete Committee. Within DOT, I am also a member of our Digital Delivery Committee, which I will talk about further in the presentation. I have a bachelor's degree in civil engineering from RPI and am licensed in the state of New York. I've been very involved with the AASHTOWare BrDR software throughout my career. I was in the private industry and consulting. I used the software there, and I've also been more on the management side here at DOT and served on various tags and was the vice president for Radbug in design until I've been in the current position I'm in now, and I have passed the torch on to one of my senior level staff, which I will turn it over to Joe.
Thanks, Julianne. My name is Joe Albert. I currently act as the president for the Radbug for design, courtesy of Julianne. I also worked on the private side with Julianne, pretty deeply involved with the program, and since joining the state in 2016, I worked with the program through design and load rating. I did serve some time as a bridge inspector and a load rating engineer before specializing in bridge design. And I currently am a project engineer for the Structures Design Bureau, among many other things. I do want to point out that the 2024 Radbug annual meeting, which wonder what Radbug stands for, it is the Rating and Design BrDR User Group. We will be hosting that in Buffalo this year, August 6th and 7th, so please mark your calendars. I know the registration has already gone out. You can get some more information by just Googling 2024 Radbug, and you'll find how to register.
Excellent. So the agenda that we have for you all today, first we're going to start by giving an overview of the history of New York State DOT and how we've used the AASHTOWare bridge rating and design software. Then I'll get into the life cycle of how we use those BrDR models within New York State DOT from a design, load rating, and asset management standpoint. Then I'm going to transfer it over to Joe. He'll go through some of the detailed capabilities of the software as it applies to load rating design. And then I'm going to jump back in and give you guys an overview of our digital delivery efforts in New York State and how we've used this software to push that through. And then at that point, Joe will finalize the webinar with giving a detailed, unique user experience and how you as a government agency or a designer, what you can get out of using this program, not just for the design and analysis of software, but the advantages that you have as a user beyond that. So first, I'd like to go through a couple facts about New York State and the structures that we have here at DOT. We have over 17,600 highway bridges. More than half of those are steel bridges, coming in at 10,300. Over 3,000 pre-stressed concrete bridges, similar quantity of reinforced concrete bridges. We have 500 trusses, 1 suspension bridge, and 8,000 large culverts. So we have a very large structures inventory here at New York State. And we have a plethora of experience of how we've applied this software to these different structure types. One thing that does kind of set us apart from maybe some other state DOTs across the country is that we do 80 to 90% of our new and replacement bridge projects or complex rehabilitations. Those are performed in-house using our own DOT staff. So we, we don't rely on consultants a lot here in New York State, and that's something that we pride ourselves in being an expert owner. And I'm happy to be here this afternoon to kind of share that experience with you. All right, so a little throwback to the history of New York State and BrDR. So this is a screenshot. We started using AASHTOWare back in 1996. Back then, for some of you more seasoned users, you may be used to hearing this called, the Virtus Opus program, where Virtus was used for the load rating side of the house and Opus was used for design. So we've been heavily involved in using the software since 1996 all the way through currently. Bit of how we use the software at DOT. So BrDR or AASHTOWare Bridge Rating and Design, that's our primary design tool that we use in-house. It's actually mandated for all new and replacement bridge projects to have a BrDR model as one of the final deliverables at the end of design. And that's whether the design is being done in-house with the staff in my bureau or if it's being done by a consultant or regional staff. In our involvement in the software, being that we've been using this in depth since the 90s, we do have New York State DOT staff that serve on all 7 technical advisory groups or tags. I think you'll hear me and Joe call it tags throughout the rest of this webinar. And like Joe said, we are the current president of Radbug representing design. So a little bit about how we like to approach our design methodology in New York State. These are snippets from our DOT bridge manual. That's the design guidance that we create for all engineers across the state for how we want them to approach their design of new and replacement projects as well as complex rehabilitations. So out of this section here, you can see the screenshot on your screen. It's that it is our standard practice for the structural analysis of straight beams or girders to utilize the line girder method. So there are situations where you might need a more refined analysis, such as a 2D or 3D finite element, but we really only want you to use that more refined analysis when you meet the specific criteria that is listed in our bridge manual. So the reason for that is, we want our designers to be using the most simple analysis that is appropriate for your structure type. So if you have a steel straight multi-girder bridge with low skew, no curvature, that's something that lends itself very well to line girder analysis. And even though we use it in design, we also want it to be used within our load ratings. So we have another requirement in our bridge manual that if a more refined analysis is not required for design, then the load rating computation shall be performed using the line girder method, regardless of the methodology that was used for design. So why do we do that? The reason is that there is reserve capacity inherently from the line girder analysis methodology, and we want to keep that reserve capacity so that it can help us with our load rating and analysis of our structure throughout the rest of its service life. So we really want to kind of save that extra capacity so we have room to sharpen our pencil down the road and, quote unquote, save it for a rainy day. We also have other requirements that you must use the AASHTOWare BrDR software for design for all of our new and replacement bridge projects. And this is another snapshot from our bridge manual, just showing how we want to use the BRD, which is the bridge design portion of the software for design, and BRR, the bridge rating portion of the software, for all of our load ratings. And again, this is a requirement whether the designs are done in-house in my group or for on the private industry and consultant design. All right, so I mentioned before that we serve on all 7 of the technical advisory groups, these tags. The tags are comprised of owners and consultants that work together to further develop and enhance the program. So we have staff across New York State Office of Structures that serve on all of these tag groups. So the testing tag, this is actually a picture of Joe and everyone else in the testing group taken from last year. This is where we get together, we beta test the software, if we have enhancements or maintenance or bug fixes, all of those we're going to be tested thoroughly before it goes out into production. So it's a very valuable involvement. The design tag as well as the analysis tag, so that's going to be any issues, questions that come up, maintenance items, enhancement ideas, anything relative to those specific topics will be addressed within that tag. We're also involved in the backlog tag, which is, AASHTOWare went through a major modernization in previous versions, and we kind of had to put some things on hold to make sure that we could get through the modernization before tackling new enhancements or new requests. So the backlog tag has been formed to help us prioritize those initiatives. What is something that is critical that will affect all DOTs, all users, and how can we prioritize ones that are maybe lower on the priority list, and how can we get funding to push those ideas through? So that's another tag that Joe currently sits on and brings a lot of value to our department. Reports tag. So I think everyone is aware that the report tool is currently in the process of being overhauled. I think that's something that we've spent a lot of time kind of getting through the mock-up phase, and what do designers, engineers, owners, what do we want in our analysis reporting or input reporting, all of that. So we have a great group of dedicated staff across all different owners, all different users that are contributing to that as well. So I guess the main takeaway here is that, we spend a lot of time and effort. A lot of this is volunteered time that we do outside of our core duties as owners and as users. But, the end result is that we have a great software product that we use for all of our bridges in design and rating. So talking more about load rating, we have New York State DOT, we perform 11,300 level 2 load ratings annually. And we do that with 3 staff in our main office load rating unit. And then we have 1 to 2 load rating engineers within each regional office. New York State is broken out into 11 different geographic regions. So we have approximately 20 total load rating staff to complete the 11,000 load ratings each year. So this cute little video on the screen here shows that it doesn't matter how many monitors you have, that still a lot of work to get done. All right, let's talk about the life cycle of our BrDR model. And this is really relative to how we do our workflow within New York State DOT. So we start with our design staff. So let's say we're going to have a bridge replacement project. We are going to create a BrDR model for that bridge replacement that reflects the design for that. At the end of our design project, we are then going to transfer that model to our load rating staff. So we're going to export our XML file, give it to our load rating staff. They can import it into their database, which I'll talk about more in a few minutes here. But then the load rating staff can then use that model for the intermittent load ratings throughout the rest of the bridge's service life. So that work up front has already been done in design, and we can transfer it to the load rating staff for them to use. But now the great aspect here of this kind of life cycle is, let's go 20, 30 years down the road. Maybe the bridge needs a deck replacement. Maybe the entire corridor, we want to add an extra lane all the way through. So maybe it's a new bridge that was designed 10 years ago, and now we need to do widening, add some girder lines, change our foundations. We can take that BrDR model that has been used by a load rating staff in their database, and we can take that and start it for our bridge rehabilitation model. So we don't need to dig out the record plans and create a model from scratch. We kind of have this living model that's been intact throughout the service life of the structure. And then in turn, once we're finished with our bridge rehabilitation project, we're going to update that model for the new designs. And then we're going to export that XML file and give it back to our load rating staff, and they can continue its use throughout the rest of its service life. So this next graphic I have on the screen here is just kind of a visual component that explains that process. And what I really want to emphasize is, we are all doing so much more with less resources, and we really need to work smarter, not harder. Why would we recreate these models multiple times as we go from the design to the load rating portion of the structure service life. And this is exactly why here. So we can look at these lines represent the duration of the tasks that it takes. So our initial design model is you're going to do a brunt of your work. So a lot of that is going to be your upfront time. We have a design model, and then you're going to possibly modify it for a level 1 load rating. And then after we transfer that to our load rating staff, now biannually at every bridge inspection, every 2 years, we're going to update what we call a level 2 load rating in New York State. So the difference between a level 1 and a level 2 is just regards to the amount of detail and precision that you are using in that load rating. So a level 1 would account for every load, all of the exact capacity, etc. But a level 2, maybe you're only updating the model throughout the service life for things like additional loads. So maybe the county's gone through and added an asphalt wearing surface. That's an additional load needs to be accounted for in your analysis. Maybe they've changed the old steel railing detail to a more durable concrete barrier. That's going to weigh more than the initial bridge was designed for with the steel railing. That's something that needs to be accounted for in your analysis. Likewise, any change in capacity. So we use a lot of salt on our roads, de-icing agents here in the Northeast. And we all know that salt and steel and concrete members do not play nicely together. So we end up with deterioration in our infrastructure. So not only are you accounting for additional load, but you may need to account for change in capacity for that section loss. So all of these level 2 load ratings account for that. And you can see, about 2/3 of the way through its service life, if we're going to do a rehabilitation, the design effort for your rehab is substantially less because we did a lot of that upfront work when the bridge was initially built. So this is really a model that we have used for decades here at DOT, and it works very well. So I talked a bit about how we kind of pass these XML files back and forth between design and load rating. And so this graph here shows our 2 databases that we maintain here at New York State DOT. We have a load rating database and we have a design database. Now the data and the users for each of these databases are very different in that our load raters that we talked about earlier, we probably have 20 across the entire, 20 staff across the entire state. The amount of users are much less than the amount of design users that we have across the state. So I have 73 staff in my bureau. We also have regional structures staff as well as consultants. So we have much more design users than we do load raters. However, the amount of data, the amount of BrDR models that the load raters work on, those are going to be all of the structures that we have in New York State. So 17,600 models approximately in our load rating database, and then we'll have significantly less in our design database because we are not building as many new bridges as we have currently in service. Next slide, thank you. So I think this is a really good introduction into what we do at New York State DOT and how we use the BrDR software, but I really want to show a couple slides here about how the entire country, how all states are using the software. So this graphic here, all of the shaded states are states that license the bridge design software. So you can see, maybe up to a half, maybe not quite, across the entire nation. And next slide, if you look at the graphic for how many states license the bridge rating software, you can see it's a majority. You're up to 90% of the states, for example. So what I'm really hoping for our users and our other departments of transportation, state agencies to get out of this webinar today is, I feel like we've done a very good job at, using the design and the load rating components of this software. And I would really like to see in the coming years to see the map on the previous slide, to be a lot closer to the bridge rating licenses. There's a lot of great capabilities of the software, and I feel like it's underutilized. And I'd really like to get the word out. And we'll take questions at the end, but my contact information will be up on the screen. If you ever have questions, I really urge you to reach out because this is a really great software program that's helped us in New York State. So with that, I'm going to transfer it to Joe so he can walk you through some of the software capabilities.
Thanks, Julianne. So I bet you guys are sitting there scratching your heads saying, oh, we don't use it for design. We don't really, we know it's capable to do with our load ratings. kind of wanted to walk you guys through some of the capabilities on the load rating side, which most of you may know, and then also on the design side, and also look forward as to where the program is going. So you guys can read all of this on the screen. I don't need to read them one by one, but on the load rating side, we do have quite a bit of different types, structure types that can be analyzed. And I want to point out for the load rating, the bridge piers there, including wall and hammerhead and multi-column pier bends. Not currently. So there are some workings, to try to get that kind of capability within the program. Currently, you'll notice in the design world, there is a substructure module right now. We are currently working to refine that. There's also like a subcommittee that I'm on for substructures. And that's really one of the perks of the program is that, and I'll touch on this a little later in the presentation, but just the fact that it's user driven, we go through these mock-ups and we work closely with the developer, and they're fantastic at getting back to us on things, and we'll test these things out, and that helps us develop a confidence in using them going forward. So really, I encourage you, anytime you're in the program, you see the new report tool, you really should be, testing out these new features, and we do beta testing. There's only so much we can do, but once it gets into the production, test it out. And maybe if you think to yourself, hey, I sure would like if this program could do that, then you have that opportunity to bring that to the developer. So there's some constructability checks that I know I've been lobbying for myself to get, because typically in design, you really don't have a one-stop shop program, and this for us is really the closest thing. So as we do our designs now, we have to, AASHTOWare requires that we make sure that the bridge can be built, and we do our own constructability checks. Well, that requires pulling the loads out of this program and putting them into another program or a separate MathCAD or Excel sheet and running those calcs. So really, I'm trying to push to get some constructability checks right within the program. You minimize user error, you save yourself time, as Julianne alluded to. Everybody's understaffed and overworked, and any kind of, even if you say, oh, that task only takes 10-15 minutes to get that out, well, it's 10-15 minutes times 11,000 bridges, and it adds up. So this is just a current list, and we are working on the bridge. It does do LRFD design for substructures, which I'll get into a little bit of that as well. So the spec check, this was part of when the program went through its overhaul. I feel that the spec check is one of the greatest things about any design program that you see. It's a LRFD spec check for all 3 stages, whether it's your non-composite stage, your short-term composite or long-term composite stage. I do want to point out that this program is an AASHTOWare program. So when the new version of the spec does come out, it is the first, if not the first, one of the first to include all the updates to the LRFD code within the spec check and within the program as well, which is very, it helps you know that you're staying up to date with the code and within compliance of the LRFD design code. So with the spec check, it'll actually show you design ratios, and you can use those design ratios to optimize your design. So, in the design world, you very rarely pick your first girder size and call it good. You constantly try to refine and make things more efficient, especially with the cost of everything today. You really need to try to economize your design as much as possible. So here's just a little screenshot of the design spec check for a steel bridge, and you'll see you have all your points of interest that are listed, and you can go from location to location, and it will give you a detailed calculation of every applicable code check for your girder. This saves quite a bit of time. And then you see the little green check mark, that means that the girder's passed. If you see a red X, that's no bueno, no good. It means you might want to look into that a little bit and see how you can get your girder to pass. So just to kind of give you an example of what you'll find within the spec check So this is one example of a specification reference at one location. The program is going to generate these same calcs at every location that the default locations you have set and any other locations you have a point of interest set for. So you'll see it gives you your limit state loading. It gives you some notes that go along with it. It gives you your design ratio. In this case, for bottom flange flexure, looks like we're pretty healthy. And it'll show you your stresses. And if you care to go and back check that with hand calcs, and maybe that'll help you establish a little bit more confidence, which I urge all my designers to. It's very valuable and it's very clear, and you can always cross-reference it with the code. There's also the steel design tool, like I brought up before, about picking your first section for your steel, your first girder size, and calling it good. Everybody has their own rules of thumb that, is a decent starting point. Well, with the steel design tool, you can automatically generate girders that are efficient. It doesn't mean that it's going to be your final section, but it's going to get you very, very close. Again, minimizing the amount of effort that you need to put in to do this, minimizing the time that it takes. We all are trying to find more time in the day. So really, you can just input your project, pick your code, input some geometry and material properties within minutes, it's going to spit out a girder design for you that will also show you what your volume of steel is for estimating purposes, and for trying to figure out which option may be more efficient. It'll give you a little schematic showing you your flange sizes, your web sizes, any kind of flange transitions that it has detailed for you. Some stiffeners, it'll give you some cross frame spacings. It pretty much spits out an entire superstructure design for you. And this also has a spec check as well. So if you're interested and you want to dive deep inside, and you can check the numbers yourself and see maybe you can economize it a hair more, something for constructability or site condition that may dictate where you can have your flange transition. You can work with that after the fact, but it's a great starting point, and it really spits out a lot of information and a very clear picture for you. So you say, oh, you New Yorkers and your steel, you guys love your steel. I know every state has a different climate, different ways of treating the roads. Maybe concrete is more of your thing. Don't worry, they got you covered. There's also a pre-stress design tool that you can use, and you can optimize your beam design there. It will give you your strand layouts, beam details, profiles. It'll show you your harp strands and where they're debonded zones. It can really, same concept as the steel design. It just gets you in a really good spot very quickly. I put these slides for the screenshots together within 10 minutes, and it had me at a nice superstructure layout. 3D FEM. This is finite element analysis. This is something that's come a long way. When I first started with the program back in 2011, it really wasn't a thing, but now the program's come a long way due to a lot of user input. And you can, if you are required to do a 3D analysis, a finite element, you can do it now. You just need to change a few things in your supports. There's plenty of training online, training videos that will really walk you through all sorts of different tips and tricks on how to make it efficient. And you can kind of see how your lateral loads now affect, and you can input wind loads, or you can have the program generate wind loads as per the LRFD code. And then it will, and it's a shell system there, so you can see all the shell elements. And you want to look at your stress maps, you can take a look at your stress maps. This also works with curved girder structures, not just high skewed structures. And again, this will also spit out a full spec check at multiple locations. So we have come a long way with the program to get it to have all these different superstructure types. Well, you're only as strong as your foundation. So why not add substructures in to try to really make it a one-stop shop? So currently there are 4 different types of piers that you can analyze. It has a wizard that will help populate some stuff with a few geometric points. And the idea is to eventually be able to go into the bridge model, have the entire bridge model. So you're not pulling your superstructure loads out to go to another program to analyze your substructures. You're going to have it all, you'll minimize human error. You'll have it all in one model. Your superstructure loads will get transferred to your substructure, and you can run designs on all of it. So currently you have a frame pier, a solid shaft pier, wall pier, and a pile vent pier. And you can choose to either have it on a spread footing or a pile supported foundation. So just a quick little walkthrough. So you just start by defining your pier type and foundation type, and you can see all of the other components that you can put in, your geometry, your materials. You can go through your reinforcement, and then there's your superstructure loads, and then you can also generate ice loads, and all the applicable loads per the LRFD code. And then once you input all of your geometry, reinforcement, it's got everything that you need, whether you want to tell it to hook the bar or not, and what size and how many, clear distances, the whole 9, and then you can generate your pier model. What I find very useful when I'm using this is that are these schematics. It gives you a 3D graphic, and it really helps you visualize your structure. You can really troubleshoot here. Sometimes you might have some fat fingers and you press the wrong button, and you're going to see it here in the model, and it updates automatically. So as you're punching numbers in on your geometry, you'll see the changes in the 3D graphics. So you can also generate all of your load combinations required by AASHTOWare. What you're seeing here, you have some wind pressures that you can put. You put your elevations in so that it can calculate its surface wind pressure. There's also temperature that you can add, shrinkage, the whole 9. So similar to the superstructure, if you can't tell, I'm pretty big on my spec check. Love the spec check. It also has the spec check for your substructures as well. So if you're interested in a certain location, just pop open the spec check, and you'll see all the applicable LRFD code checks right there in front of your face. Sorry. And one of the really big benefits is that you can have your entire structure in one model. And with that, I'll let Julianne get into a little bit more of that with the industry and where we see the industry going in the future, and why this is something that's beneficial, not just right now, but also going forward.
Great, thanks, Joe. Yeah, so I'd really like to talk about one of the more exciting capabilities of this software and how it's related to IFC files. So an IFC is an industry foundation class. So the file is basically a model file that is created that can be used. It's an open file format, so it can be used by any BIM program. So it contains information about a model, including spatial elements, materials, shapes. So it's basically an information model that can be opened in a variety of software programs and a variety of needs for them. So next slide, please. So currently, AASHTOWare BrDR can export models into the IFC 4.3 format. And what that does is it allows the design models, whether it's your superstructure, substructure, or both, to be exported into this file format that can then allow the design user to import them into different modeling programs. So you can generate 3D models of your superstructure, your substructure. You could put it into a modeling software, a CAD software, to create your contract documents. So whether those are 2D plans or 3D contractual models, You can also use them on the fabrication side of it. So what we need for design, the models and the information we need for design are not always exactly what the fabricator is going to need during construction. So we can take with the IFC, you can take the pertinent data from the design model and they can import it into their fabrication software to eliminate a lot of that data reentry. We can also use it for construction models as well. And then, you know, the ultimate goal is to use it for asset management. So really the industry as a whole is really interested in these IFC files and how can we really transfer all of this digital information, this digital data, not only from design to construction, but also into asset management. Next slide, please. So to really kind of hit this point home, I just want to give a little bit of an overview of our initiatives related to digital delivery at New York State DOT. And then I'll circle this back into how this all kind of ties into IFC and the work that the AASHTOWare was doing specifically with this BrDR software. So looking at these images on your screen, you know, the pictures on the left are kind of how we used to do things 30 years ago, and, you know, maybe even as recent as 10 years ago, you know. So we used to draft everything by hand. We don't do that anymore. Now we're into our CAD software. We're in our cubes, our multiple monitors. You know, that's how we're preparing our contract documents. But even until recently, you know, the contractors always want to have their papers in the field, their 11 by 17 plans, their big roll plots. And that's how they built our infrastructure for decades. But now we're really seeing a shift in the industry and how, you know, maybe they're not holding plans in the field. Maybe now they're holding tablets. And how can we give them our design information to be able to use electronically in the field? So at New York State DOT, our digital delivery effort is really, you know, we don't want to be taking these very smart 3D design models or even contractual models. Maybe you're in your CAD software and you're taking your design data and you're modeling it in 3D. But then what do we do? In the past, we've gone through and now we kind of flatten all of that to these, you know, kind of dumb 2D plans. So we have all the smart information that we're kind of dumbing down to give to the contractor. And now the contractor is utilizing these emerging technologies and how he can use that 3D information to build the bridge, to build our structures. So what digital delivery does is it kind of cuts out that middle part where we're creating 2D plans and we want to take the smart information models from design and transfer them directly to the contractor through to construction. So we have completed 2 pilot projects in New York State. The first is Route 28 over Esopus Creek. This was a very rural environment, large multi-span bridge. This was a great project for us to kind of get our feet wet. And when I say that, we just dove headfirst into the deep end on this because we went full model-based contracting. So that means all of the contractual documents were in 3D models. So our superstructure, our substructure, our foundations, our highway design elements, everything was provided to the contractor in a 3D model. Our second pilot project, East 138th Street over the Major Deegan Expressway. This project is currently in construction. And these 2 projects could not have been more different. So the first one is very rural. We had a lot of space to work with. Our second project down in the Bronx is a single span structure. So maybe structurally not as complex, but you can see the graphic, the rendering on the lower left-hand side of the screen here just shows we had a very complicated web of utilities. You know, in the city, I think they just build and keep building right on top of whatever was there before. So there's a lot that we had to coordinate in order to build this structure. So, you know, 3D modeling was really an excellent choice for both of these projects because not only is this the way that the industry is shifting, but this was a way for us to utilize the 3D models from design to construction. Next slide, please. And, you know, I really want to boast that, you know, AASHTOWare BrDR is at the forefront of IFC file compatibility. You know, if you look elsewhere in the industry, other software platforms, they're starting to think about it. There may be, you know, oh, that's something that we should incorporate, or, you know, maybe they only have half file compatibility. But, you know, AASHTOWare is actually working towards IFC 4.3.2, which is certified by ISO. And really the key with these IFC files is that what I need in design, as Joe was saying, you know, what can I do for my spec checks, for my design documentation, the information I need in design is going to be vastly different than what the contractor needs to build the structure, or what the fabricator needs to input into his software to actually fabricate the steel girders, for example. And IFC is really the key, and that's what's going to take our BIM from design to construction and eventually through asset management. So, you know, you can see your graphics here that before BIM, we were very siloed in how we did our work. Everyone was independent, and we would do our job and then transfer the key information to the next stakeholder down the road. But, you know, including BIM, which is really IFC, that's going to be the key for us in structural design. We're really going to have a whole life cycle of our data instead of being in these silos where we're reproducing work unnecessarily. So I just want to point out that, you know, both of our pilot projects, all of our designs were done in the AASHTOWare BrDR software. So we did the designs in BRD, and then we used the information to create our 3D models, which were then transferred to the contractor. So we have a lot of hope for this software and how it's going to contribute and continue to contribute for digital delivery within New York State. Next slide.
Thanks, Julianne.
Yep.
Yeah, so I kind of touched on it a little bit through my previous slides, but I just want to go into a little bit more detail about how this program really offers a unique user experience. It's user driven. You know, we have all these tags, these technical advisory groups that are comprised of state DOTs. There actually are a couple of consultants as well. And really, we try to work on enhancing the product and getting it to each state-specific needs. Now, at the end of the day, you know, each state is going to be a little bit different. Their needs are going to be different. So it's a good way to also hear about what challenges other states are going through. Maybe they've solved the problem that you're currently going through. You hear about all these things, and you can expand the program's capabilities. I use this at last year's Radbug, but it's like, you can't go ask Microsoft to bring Clippy back. It's just not, they're not going to do it. Whereas when we work with the software developer here, and if there's enough states on board that really see that the program is, you know, needs to add something that's beneficial to multiple states, it'll get done. It'll get put into the program, and you'll work with the software developers on how it gets put into the program as well. So, you know, we've championed, New York State's championed multiple enhancements over the years to really help economize our design process. You know, I urge other states to take the opportunities to do that as well. I can go into the enhancements in a little bit more detail. So, service units. So, being that it is user driven, you can purchase service units with the program license, and that's kind of how you can start to customize, have the program customized to what you really need. And the service units can be used, you know, for enhancements, so like I've kind of been harping on, as far as custom additions into the program that you may find that you need, or just training. You know, we've had a huge influx of young staff coming in, you know, on the design side, and they need a lot of training, and there's not a lot of senior level staff that, you know, there's only so many hours in the day that senior level staff can train. So we use some of our service units to set up training classes directly from the vendor. And you know, we were able to save ourselves a little bit of time and train the, you know, a lot of our newer employees. So you have an idea, right? You want the program to do something specific that's been giving you a headache for years. So you have options, right? You can either fund it with your own service units. Now, I want to point out the service units roll over year by year. So one of our strategies in New York is we will buy service units, you know, yearly, let them stack up a little bit so that we can go after something large, you know, a larger enhancement that really would help us out. So you can either fund it with your own service units. Say there's another state that's just having the same, you know, the same needs that you do. You can pull together with other states as well and combine your service units and try to get what you guys want in the program. a little Radbug snippet here is, you know, if you are, I encourage you guys to join Radbug, because a lot of these enhancement ideas get discussed, and you find out if other states have the same kind of interest that you do, and you can team up right there. Or if you know, if there's enough people on board and there's enough need, you can escalate the idea to the task force for stewardship, and the task force will basically pull all of the different state agencies and try to determine how much of a need this really is. And if it is a big need across the board, you know, the task force will work to get that enhancement pushed, or that change to the program pushed. And once you have those wheels in motion, you'll start to work with the software developer. They'll start to create mock-ups. You know, there'll be a lot of back and forth. Then you'll get into beta testing. The testing tag will test it, and you will also have an opportunity to test it in an unreleased version of the program. And then you see the fruits of your labor come to fruition, and in the next version, or however long it takes, in a newer version, you'll see the rollout. So one enhancement that we just went through that you'll notice is in 7.5 is the flange lateral bending tab that's under your lateral support. So this is an example of the mock-up. It looks like somebody's kind of piecing it together like a ransom note kind of thing, but they're kind of showing you, is this what you want? And we commented, we went back and forth, we held some meetings of how do we want to show it, what kind of checkbox, what kind of toggles do we want? And you know, as a bridge engineer, I have no idea what goes on behind the scenes on the software side, but ProMiles is very good at that. They know both sides of it, and you can kind of discuss, well, I want it to do this. And they're like, well, what's the benefit of that? Because it's going to take an extra year to program the programmer like that. And we come up with all these different solutions and find a nice little balance. And at the end of the day, there it is. It's actually working buttons, and it's not looking like a complete ransom note. So with this enhancement, you know, we did work hard on it internally, but we've kind of started our constructability checks. As you can see, that we've created a construction stage now, where we can input some lateral bending into our flanges, and you know, kind of check the bridge before it's in its completed phase, and everything follows the code. You have different options on how you want to toggle it on and off. And again, all of this information is in the spec check. It's in the help menu if you hit F1 under this tab. So it's not just, oh, we're just going to add this one little tab here. It was a full-blown effort. You're getting it in your spec check, your help tab, and your end results. So just a quick little example of you know, an enhancement that we just championed and went through. So speaking of that, again, I'm going to harp on Radbug again. August 6th and 7th. Mark your calendars. Try to get on and register. You know, it's a good opportunity to network with other state DOTs. You know, you can work on teaming up with other states to champion some enhancements, make the program a little more custom to what you want. You can get involved in tags. I highly encourage it. It's worked well for New York State DOT over the years to really be involved in these things, and really helps facilitate our needs. It's a win-win at the end of the day. You know, the vendor will hold some training sessions as well. And if you're feeling up to it, August is pretty nice in Buffalo. I know everybody just thinks of the 6 feet of snow that they just got a couple months ago, but it is beautiful in the summer, and you know, you can take a ride on the Maid of the Mist, which is a little boat that'll take you at the base of Niagara Falls. So highly encourage people to register for that. It's looking like it's going to be a good turnout. And thank you very much. I think there's been some questions flowing. 20 of them are answered.
Yeah, so let's start with, we have time to answer a couple of questions. Let's see, what is the future for BRR in terms of modeling complex structure, curved bifurcation, steel caps, kicker beam, bridges, etc.? BRR is currently limited to curved bridges. Someone would like to answer that.
Yeah, I can take that. So currently that is an enhancement idea that we have in right now. It's in the backlog for, well, with complex curved structures. Basically right now the program does, if it's curved, it's curved. You can model just the curve span, the curve portion. There's currently a enhancement ticket in to try to get the program to do tangent, curve, tangent, set up some different types of geometry for what you're talking about there. It hasn't been escalated yet, so if you are part of a state DOT and you're interested, there's some contact information right there. And maybe we can talk about that a little bit further.
Yeah, and Joe, I just want to add to that this software is ever evolving. So one thing that I really try to push within my group here at DOT is, don't get that stuck in your mind, because there were versions previously where AASHTOWare couldn't handle the curve girder analysis. It wasn't something that was handled that could be performed easily. And there's been a lot of enhancements and improvements in the last several versions, and now it's something that you can run your 3D finite element analysis and do your curve girder analysis, do your higher skews. Like the truss analysis capabilities have increased exponentially through compared to previous versions. So that's something that I want everyone to continue to be open-minded. Don't get it stuck in your head, oh, it doesn't do curve girders. Yes, it does do that now. And maybe some of these other structure types that are not supported during the current version, if we can get these enhancements pushed through, that's something in future versions it will be. So that's one thing that I've learned in my experience is don't think that this software is static because it doesn't have the capability. That doesn't mean it won't in the future. Like, that's really not the purpose of what we do. All this time that's spent on these tags, we really have the ability to shape this software. So Joe's answer is it doesn't currently, but not yet.
You're not the only one asking about it, so
yeah.
that's kind of the
question. Someone asked what CAD software you use.
So in New York State, we are licensed with Bentley. That's where our current CAD contract is through. So we use MicroStation and OpenBridge Modeler and OpenBridge Designer.
Gotcha. Okay, I think we have time for a couple more questions. Let's see. Wondering if BrDR will include fatigue analysis rating in the near future.
So similar to the design side of enhancements and changes and customability, there's also the load rating side as well. So if you feel like you have a need for that, that's something that you can work with other states. And Radbug is a great place to do that because it is both load rating and design engineers there. So our load rating group is also involved in the tags that are appropriate as well, and they try to champion their own enhancements too. So that if there is a big need for that, that's something that maybe you want to show up to Radbug and see if other states are really are on board with that. That might help you out.
Absolutely. If you go look at the chat section of the webinar, I've listed out a couple of links. One of them is to the Radbug for this year in New York and Buffalo. Another one is for a survey to get some ideas for presentations for not just Radbug, but also future webinars on some of these items that you all have questions about. Could make some good webinar topics, so stick them in there, as well as this recording of this will be on our YouTube channel as well. The link is there. I think we have time for a couple more questions. Does New York
Ben,
State?
I think
do you want to go?
Yeah, I tagged one of these. I think if we have time for this one, the question is, what was the contractor feedback from the IFC pilot project, as in the as-built and change order process fluid? So that's a really good question. So I mentioned that we've gone through design on 2 pilot projects. We're actually in planning for our 3rd. And with the first project, we provided everything in 3D models, all of our contractual information, including the superstructure. And we really took a lot of lessons learned from the first pilot project to the second, because the steel fabricators pointed out that, modeling our steel girders in 3D in the as designed case were not extremely helpful to their fabricators. So we did the final situation under all deflection and dead load once all the loads are applied in the field. But the contractors and the fabricators are really interested in, their fabrication models. So we kind of switched gears for our second pilot project, took that feedback into consideration, and we provided different types of electronic information. So we also provided 3D models for visuals for as supplemental information, but our contractual data for our superstructure was actually in Excel spreadsheets. So we were able to provide something similar to like girder schedules, where we gave working points, offsets, flange transitions, diaphragm locations, everything that we had in our AASHTOWare BrDR model, we provided in an Excel spreadsheet format to the fabricator. So again, it wasn't the complete 3D model for them that they could just plug into their fabrication software, but they were able to use the spreadsheet data to limit data entry, which they would have to do if we provided 2D plan sheets. They would have to take the information from the girder schedule and physically input it into their fabrication software. So I feel like we're still having our conversations with the contractors and the fabricators for how we can improve this. But what I found in our outreach to the industry is that the IFC files are going to be the way to do that, because then we can go directly from BrDR to their fabrication software instead of us having to export out of BrDR into a spreadsheet, and then they're taking the spreadsheet information into their fabrication software. So I think it's definitely a work in progress, but we're getting on the right track, and just having those conversations for understanding the best exchange of information is really the best way to go about it.
I think we have time for maybe one more question. Do you want to pick something from the list?
Yeah, so I think there's one more on here. The question is, does New York State DOT use BrDR as a one-stop shop for design, or are additional computations and other programs or hand comps required? So I think this is a great question too, because we looked at the map earlier and we saw that there's not a lot of states that are utilizing BRD licenses. They're more on the load rating side of the house. And when you're going to take that step and venture out into making this your primary design software, you are going to want to do your hand calcs to, verify the spec checks, understanding, the design solutions that the software is producing. I saw a couple questions about that during Joe's portion of the presentation. And that's something that we do too, even if it's enhancement that we have funded in-house by New York State, or if it's an enhancement from another state, we don't just blindly take the results out of the software. Like, you need to do your due diligence, do your hand comps, or maybe you have another in-house spreadsheet to verify the software. And then once you get that comfort level with it, then it's something that you'll be much more comfortable using as your go-to one-stop shop for design.
Okay.
Any other questions?
We are at time. We could probably do one more. Again, from the list of questions we've got, but we're slowly running out of time.
All right, I think we've got one more that we could probably handle pretty quickly. Says the huge challenge of using finite element is analysis time, and how does New York State DOT handle that? So Joe, I know that you've written up a couple lessons learned about that. You want to just touch on a few of them?
Yeah, I have a whole tips and tricks thing for running 3D FEM. Part of the problem with the analysis time is also on our database side, which I know that I've spoken with Jeff about and the ProMiles team. And once the cloud-based database, services come aboard, that's going to help fix some of the analysis time issues. At the end of the day, you are just processing a lot of data. The file sizes get really big, so you just got to keep that in mind. But what I typically tell my designers is just to run your model as dead load only to start. That should run very quickly. Then after that, just run the live load. You can do all this in your analysis settings. And then the live load might take a little bit longer, but it's still not too bad. And then from there, run your spec check separate. So you want to kind of do these all separately so you don't completely bog down your computer. And then once you run your spec check, then you can go and check on your diaphragms that you want to see the spec check for. So the first spec check will just check your primary members, and then you run the spec check again for your diaphragms. And so it really cuts down on the analysis time quite a bit by doing it that way. You can modify the number of shell elements if you want in your analysis settings. If you're interested, I can send you my cheat sheet that I have. Feel free to shoot me an email, and I'm more than willing to share.
And hey, Joe, I can add on to that too.
Yeah.
So the 3D analysis that's in BRR is really like the first implementation of it. I mean, you can make the argument that maybe it's like version 1.1 or 1.2 because we have tweaked it over the years. But we are aware of a lot of performance improvements. As Joe mentioned, it is doing a lot of computations. It's a very, very thorough, complete analysis, and it's not like a grillage analysis or something that's like a shortcut. It's doing a full 3D analysis. But that said, we are working towards an engine 2.0, and we're working towards improving the full 3D analysis. And I think we have a lot of things that we can do that we've identified that will greatly improve the performance in one of the future versions of the tool.
Great, thanks.
Right, thank you. I think we're at the end of our time today. I'd like to thank Joe and Julianne for an awesome presentation. I'll give a virtual round of applause, the task force and the folks at ProMiles. I hope you enjoyed today's presentation. The recording will be available on AASHTOW TV under Bridge Rating and Design. I hope to see you again soon. Have a good day.